Welcome to Physics with Mr. Brazil. Today we're looking at Hooke's law. We have a spring and a massless pulley also, and the spring is massless. It's attached to an Atwood Pulley System. Two masses, a 15 kilogram on the left with the spring, and on the right, a 20 kilogram mass. And we want to know the distance that this spring will stretch, especially upon release, but even sitting there, it will stretch a certain distance. So the spring constant is 680 Newton meters. So we're gonna figure out what it's gonna stretch as it is in motion, okay? We're gonna take this cord and mass system and put it in the X direction. Here's what I mean. I'm gonna take the weight on the left side, that's the 15 kilogram. It's gonna be pulling to the left, so it's gonna be a minus direction. We have the spring, it has a force, and it's going to be pulling to the right, and that's going to be a positive direction. Okay, if we were to take the cord and stretch everything in the X direction, we'll put the pulley right here. We're going to have a tension on the left side, T, and that's going to be negative because it's pulling to the left. And we have the weight, FG20, and that's going to be positive because it's pulling to the right. And this whole system is accelerating to the right. So the net force is going to be the total mass going at some acceleration A. So let's find that acceleration A. Okay, so let's write our net force, Fx. It's going to be minus Fg15 plus the spring force minus the tension force plus the force of gravity on the 20 and the total mass times the acceleration, and that's going in a positive direction to the right. Since the heavier mass is the 20, it's going to pull downward on the right side. Also, you'll notice that all of a sudden there's 4 different forces. Well, actually, yes, but with the spring, just if you were to hold the 20 kilogram mass and just let the spring stretch, that force will be the same as the tension on the other side, and it'll be the same for while it's in motion. So over here on the right side, the spring, the force due to the spring is going to be equal to the tension. Okay, since they're equal and they're in opposite direction, these two are going to be zero. They're going to zero each other out, so they're not going to even show up in the math. So A equals Fg minus Fg15 plus Fg20 all over the total mass. Okay, I'm going to write out the variables. So I'm going to make this go M20 minus M15 times G all over M total. Okay, so let's put some numbers in. So that's going to be our 20.0 kilograms minus the 15 kilograms times, I'm going to go 9.80 meters per second. Okay, and all that over 35 kilograms. Okay, 20 plus 15. All of this is going to equal 1.5 meters per second for this system. Good. Now, if we know that, and we were to cut this pulley in half, let's do that, and just take the left side, the forces on the left side, so it's going to be accelerating upward, we can write a net force, and I'm going to do it in the Y direction, here in green, so in Y. So that means we have a positive force spring minus Fg15 equal to the mass of 15 at the acceleration A of 1.5 meters per second. Okay, let's solve for the force spring. The force spring will equal M15A minus, plus, because it's going to the right side, so that's going to be M15G. Let's put this, factor out the M15. That's the 15 kilograms, and A plus G. This makes sense because since the left side is pulling up, there's going to be a little more tug, okay, going upward on the spring. Let's add some numbers. So 15 kilograms, 1.5 meters per second squared, plus 9.80 meters per second squared. And that's going to give us the 2 sig figs, 170 newtons. Hey, once we have the force spring, we can apply Hooke's law. Hooke's law states that the force of the spring is equal to the spring constant times x. Therefore, x equals F spring over K. So 170 newton over 680 newton meters. That's going to give us 0.25 meters or 25 centimeter stretch. And that is our answer. Okay? Hey, if you need to, slow down this video. I always recommend do the math as I do it too, so that you can understand how to do the process. Keep practicing physics. Until next time. Bye.